There you go, 9 a.m. Okay, good morning, everyone. How are you guys doing? Good to hear. So welcome to today's presentation. Today I'll be showing how we use integrator streaming views to do real-time analytics. Sorry. Oh, I have the, okay. Let me first start introducing myself. My name is Rafael. I'm a technology enablement engineer. That's a fancy name for a software engineer that deals with the community. I don't know how frequently you guys are on Pi Square, but you may have seen me there. I mentioned here before, I'm from Portugal. I work from the London office. So if we have EMEA customers here, EMEA partners, and you want like a local support for what I'm going to show here, questions, you can hit me up later. So today we're going to show how to use streaming views for real-time analytics. We will go through what we're going to do, why we're doing it, how we're doing it. I will briefly talk about OSIsoft and our relationship with CrispDM. You may have heard about CrispDM. I'm talking a little bit about it. I will present a architecture and the data flow that we're going to use here. You can take it like a live architecture reference. And we are doing a live demo, but the live demo is not a final bullet. It's just we are going to go through the process live. So when I mention that it's live, it's really real life. I will be doing everything here. I will be coding here. I will be configuring the integrator. I will be doing everything, so that can be very, very much fun. So before we begin, this is a tech talk. It's a different format. It's not a traditional lab where you guys have your own computers. It's not also a lecture. It's different. It's very informal. It's very interactive. We'll be doing everything here. There will be time for Q&A later. So if you have questions, please ask them. And it will be very dense. We will cover a lot of things here. So that's why I said that I wouldn't be surprised if some of you leave during the presentation. When it comes to technology and software development, your mileage may vary, so don't be a stranger. Ask questions. It's not a big deal. I'm here to help you guys. So let's start with the what, the why, and the how. What we're going to do for another time, we're going to stream live data to an external server. We will process it. We will get the results back, and we'll bring it back to Pi. Right now, you may not understand why that's important, but the reality is, Pi is great for several things, but it's not a solution for everything. There are some platforms that are better for other things, like, for instance, analytics. Spark is a very powerful and capable analytics platform, and you should use it to do real-time analytics and machine learning. So why not use it? And that's why we offer the PI Integrator, to allow you to send data to a Spark machine to process it and to send data back to Pi. And how I mentioned, we're going to use Streaming View, Kafka, and Spark. You guys are familiar with Kafka and Spark here? Okay, great. Okay. So let's briefly talk about CrispDM. If you guys belong to the data science world, or if you have any sort of relationship with data science, CRISP is not something new for you. CRISP stands for Cross-Industry Process for Data Mining. CRISP, that's the DM. And that's the CrispDM. So the idea behind it is to solve a problem using data. You have a problem and want to solve it. How do you do it? How do you start? First, you have, it's kind of hard for me to read it. So you first have a business challenge. And you have to understand the data behind your challenge for you to try to solve it. So you start understanding your problem, and once you understand the problem, you have to understand the data behind that problem. You have to understand what pieces and bits are responsible for impacting and influence your problem. And once you have that, you have to go through a process called data preparation. You get data and you prepare data. You can, most of the time, you cannot use data as it is. You have to prepare. You have to change it a little bit. We have to go through data wrangling, and I'll talk a bit about it a little bit later. And once you understand your problem, and once you understand the data behind your problem, and once your data is prepared, you have to model something that solves your problem. And then comes the modeling part. And once you have a model ready, you evaluate that model. And if it's good, you can deploy your model. And if it's not good, you go back to the business understanding and try to understand why it was not a good model and what you can do to make it better. And why this is important to talk about? It's because you can see it all goes around data. It's all related to data. And when it comes to data and industrial data, it's PI. So we do offer some products that are able to cover some of the parts of the CRISP DM. For instance, the data ingress, like the interfaces, the connectors. You can write your custom code to send data to PI. The data understanding, you have some data exploration tools like Vision, Data Link, Power BI. You can write your own custom Python or R scripts or any language that you want. Those are actually my favorite. That's why they are here. The data preparation part, you can still use PI. You can use Data Link. You can use integrators to do it. But also, you can use your own code. You can use AF SDK. You can use PI Web API or PySQL. And those are the parts that we are good at. And then comes some parts that we don't do. And let's face it, it's not our expertise. And modeling, for instance, you need third parties. You can use your own Python script, R script, Spark, that's what you're going to use today, Jupyter, Flink, Hadoop, whatever you want, you can use for modeling and for evaluating and deployment. So today, what we're going to do is this. So this is the environment that we have that we're going to play with today. I have the data generation server. And by server, I'm being very, very nice here because it's this guy here. This guy here is generating a ton of data to a PI server that I have on the cloud. And it's, so the idea here is to simulate, and I'm going to talk a little bit about what I mean by simulate data, generic data, not a specific data. We are sending the data to a PI server. The PI server is sending the data, is streaming the data to a Kafka server through the integrator for business analytics. The Kafka server is able to talk with a Spark cluster. The Spark cluster is able to apply some machine learning to the data that I'm sending there. The results are going to be sent back to the Kafka server. And just for the cherry on top of the cake, I'm going to send data back to PI using NodeRED. Do you guys know NodeRED? No, okay, so that would be fun. Yeah, no, it would be really fun because it's really nice to use NodeRED. So, just a little explanation here. All the servers, the Windows servers, they are inside a domain. It's called Tech Lab. It's a domain, it's an actual domain. And the idea behind putting the Spark cluster on the cloud is to allow a bigger processing power. So if I need more power to process my data, I can easily increase the cluster size. That's why it's on the cloud. So let's start with the data generation here. I'm going to simulate a wind farm for no particular reason than the fact that I think they look cool. Wind turbines are very cool. And so what we have here is this guy here. It's generating data, and it's sending to PyWeb API. I'm going through the code in a moment with you. There's a second server that's on my desk. Craig's here. Craig works with me in London. He have seen this computer. It's a Raspberry Pi running a cluster of containers. And there are several containers here. You'll see in a moment. It's running on my desk. Of course, I have a backup on Azure. And the way I'm sending data to Pi is through PyWeb API. And it's very simple to do it. We frequently see on PySquare people asking, hey, how do I use PyWeb API? It's so hard, it's so complicated. What's your preferred language to use with PyWeb API? And the PyWeb API is a RESTful endpoint. So it's an HTTP RESTful endpoint, so you can use any language that you want. You can use whatever you feel comfortable with. And when people say to me, hey, it's hard to use PyWeb API, I said, no, it's not. So here is an example, an actual example. That's the lines that I'm going to run today. I'm generating data. The data has a timestamp and some information. I'm just doing a post. Here, I know that I have a laser pointer. No? Oh, there you go. You can see here a post. I'm just requesting the engine, the Python engine. By the way, I'm using Python just because I think it's easy to understand. No particular reason here. For a specific URL, and in that case, it's the Web API endpoint. Some headers. I'm talking about the headers because it talks about security here. And the body. The body is pretty much a JSON with the data that we want to send to the Pi server, the PyWeb API. And the response is just the response from the server. And so let's go through our code here. Let's stop for a moment. So, yes, that's it. So, let me. It's a problem to be blind. So I mentioned that we're using random data. And that's a little bit of a lie here. And I would like to present that to you because I think that's interesting for testing purposes. Maybe that would be useful for you. It's not related to Pi, but it's related to what we're doing here. So I'm going to spend a minute talking about it. So I'm not generating actual random data. So what I have here, on my email, it's open. Let's close my email. I have nothing to hide here, just to, I didn't know that it was open. That's weird, because it's not. Okay. There you go. So what I'm doing to generate data, we're talking about machine learning, so it's kind of pointless to generate random data and try to extract information of it. So what I'm doing here, I have a correlation matrix that I manually wrote. And for those who don't know what it is, a correlation matrix, it's just a matrix that gives us a, oh, what's going on? I keep closing, and it's Chris Nelson's, the VP. You have to read it. Yeah, yeah, maybe it's from HR. It's not, yeah, it's not closing. Wow. Okay, never mind. Let's pretend it's not here. So let's go back to the code. Much more fun. So what it does here, it says that for a specific, maybe it would be better to use this. For a specific variable, let's say B, it has a 0.8080 correlation factor with variable H. Variable F has a very low correlation with variable D. So I can create a matrix of correlation so I can simulate data that we want to analyze. So that way we can actually get something that will be pretty close to this guy here. If we have people who understands math a little bit more, they will know that it's impossible for us to use this matrix as an actual correlation matrix. So I have to go through a process to get the actual correlation matrix that I can use. A correlation matrix must have some statistical properties that are very hard for us to do manually. So there is some math behind it. I'm not going to show you. But the idea here is to get this correlation matrix and this average target here. So what I'm doing, I'm generating 10 random streams of data. And A will have an average of -5 over time, B -4, and that goes on through to J. And they, over time, they will all have these correlation matrix. And that's it. That's pretty simple. So now let's go back to my code here. So what I'm doing, it's actually pretty simple. You can see here. By the way, do not take this as a good example of Python programming. I'm just trying to be didactic here. I'm not trying to teach you how to code. So what I'm doing here, every 2 seconds, I'm asking the server to generate a new batch of random data, and I'm sending to Pi. So you can see here, it's less than 10 lines of code. I'm generating data and sending to Pi. So let's go to the send method. It's here. I'm sending this guy here. So the send data, what it does, oh, by the way, let's go back to the app here. I have all the variables mapped here. I'm doing it manually just because I want to be very clear about what I'm doing, but you could easily make a request to the Pi Web API and get this information, and then you don't need to do it manually. But what I'm doing here is just setting some colors for the streams of data and the path from the AF server where the data is stored. And this path is pretty important because do you guys play with Pi Web API frequently here? Okay, so let's go back to the presentation. In the past, it was a very, very complicated problem when it comes to sending data to Pi because you would have to do 2 requests at least. The first request to get data belonging to that specific element or Pi point that you want to send data to, and to get the web ID. And from the web ID, you do a second request for you to actually send the data. Since Pi Web API 2017, this is no longer required. So you can, if you know the path of your element or the path of your Pi tag, you can easily generate the web ID. So this is an example of how you do it. You have the marker and the owner marker. You may be wondering, what is this? It's just a table that you have to check. The table is available online. You can search on PySquare. In our case here, we know it's an attribute, so the marker is AB. We know the owner of that attribute is an element, so it's an E, and that's it. The path itself, you just encode with on B64. Once you encode it, you get the string, you concatenate everything, and that's your web ID. It's much more simpler when you know a little bit of more information. And the same goes back. If you have the web ID, you can actually decode it and extract information from it. And let's go back to. And that's what I'm doing here. So that is actually the same code that I'm using to generate the web ID right here. So what I do, you can see here, when I send the data, let's go back to here. When I send the data, where is it? Send the data. I'm sending a timestamp and the new data and the variable info here. I'm actually interested on the path. So what I do, I can't read it. Okay, so what I do, I have to create the body. The body, it's a JSON body that will contain the data that we're going to send. And you can see that I'm only doing a very simple transformation. I'm generating the web ID from the path that we have. I'm adding the timestamp, some unit of measurement, some metadata to the data, and the value that we want to send. And that's it. That's all I need to send data to PI. You can, oh, by the way, there's a little bit more. But everything in 67 lines of code. It's actually pretty simple to do it. And let's talk a little bit about the header here. So our Power Web API, the Power Web API we are using today, it uses basic authentication. I'm not going to use anything more fancy because, you know, it's live. But you could use Kerberos, you could use claims. It's just a matter of implementing the protocol to your application. And so let's go now to our server. So, okay. I can't read it. Okay, there you go. So now we have our application running. And it's already generating data. So let's see how it is. Where is my virtual machine? Okay, here it is. No, that's not the virtual machine. I'm a little bit lost here. Okay. There you go. So if you go to that's the one. So that's colorful, and that's it. So we're generating 10 random-ish streams of data. Something that I should mention here, this software, this piece of code that I'm using, I was actually able to generate over 10,000 data points per second. The reason why I'm not doing it is because it's really hard to see 10,000 data points at the same time. And by the way, I'm using this guy here. So, all right, we don't need that anymore. Let's go back to the presentation. So you can see all the requests here. Okay. So there you are. Now we are generating the data. We are using PI Web API. We are using basic authentication because we want to, but we could use Kerberos if you want. We're encoding the web ID using the path, and that's it. It was pretty simple so far. So, all right, data. Oh, and by the way, let me show you something before we talk about the integrator. I mentioned that we're talking about turbines here. we're simulating turbines, and that's the structure that we have on our AF. It's not a big structure here. I'm not trying to show how good AF is. So it's just a very simple structure. We have the 10 turbines, and each turbine has a wind speed, and that's it. And if you wonder why we have negative wind speed, you're a smart person. Actually, you can have negative wind speed. It's just going the other way. So, well, now we have the data flowing to PI. And what do we do with that? So we have the PI Integrator for business analytics. And in particular today, we're going to use the advanced edition. So the PI Integrator for business analytics is able to transform PI data and allows you to send data in any shape you want to pretty much every platform available today, and using several different protocols. You can send data to Power BI, Tableau, Spotfire, ClickView, and the Advanced Edition allows you to stream data. That's the big difference here, and that's why we are going to use the Advanced Edition. And these are some examples of platforms that we support right now. That's not all of them. It's much more comprehensive. And the PI Integrator 2018, it's able to talk with Kafka. And that's what we're going to use today. That's what we're going to send data to. So let's stop here and go to our integrator. And that's the integrator, all right? So who here has used the integrator before? Oh, several people. And who is using for streaming? No. Oh, so that would be good. You guys are using? Soon. Great. Awesome. Oh, you're using?
A little bit for vehicle data.
Vehicle data. Nice. Oh, I want to talk to you later. Okay. So I'm not going to explain everything here. I'm just going to show you how you do it. It will be much more fun. So when you create a streaming using the integrator, you have to first create a target. It's administration, and then targets. There are several Kafka servers. We're going to create one here. And it's actually pretty simple. You just click here, and by the way, those are all the platforms that we currently support with the 2018 version of the Advanced Edition, the Integrator Advanced Edition. We're going to use Kafka. And we are going to okay, it's really hard for me to read. Let's do the following. It's already here. So it's actually pretty simple. I just added the IP address of my server and the port that we're running the server, and that's it. If you're using any specific authentication mechanism, you can specify down here, and you can input your certificate, user password, whatever you use to protect your Kafka server. In our situation here, I'm not using any authentication. It's not open to the internet, so I'm not concerned about security, and it's also a demo. I don't want things go wrong. So here it is. It's actually pretty simple to configure. And once you do it, let's go back to my views. Let's create, there's this option here, create a streaming view. All right. The way to do it is actually, this is the stream view name. Okay. You just name it. It's like tag lab view. Create view. now we have to define the way we want the shape of our data to be. And by shape, what I'm saying here, we have to select the data source, data that we want to see, and how we want to format it. So let's go to our wind farm. I don't know if you guys get the reference here. Good. Extra point for you. And okay, let me expand. So turbine A, wind speed. All right, if I drag this guy here, it's only going to bring data for turbine A, and that's not what I want. I want to see data for all the turbines. So what you have to do, you go back to here, and instead of the asset, you change it to template. I'm using a template for my turbines, so I'm able to save it now. And then instead of only seeing turbine A, now I have all the turbines here and their respective wind speed. Okay, that's what I want. Now, if we get the data, or if we go to the next page, we're able already to see an example of how the data is going to be sent. Here, you're able to format a little bit more. You can easily change. Let's say I don't want wind speed. I don't want to deal with spaces. So speed, let's change for speed. Valley, okay? Update property. I don't want also to deal with caps. Let's go. There you go. So very simple. We have a JSON with the speed, the turbine information, and the timestamp. And that's it. Nothing special. Now, if we move to the next one, we can define our target. In our case here, it's Kafka 2, because I was too lazy to create a new one. And we can define our topic. I'm going to talk a little bit about topic. What is a topic? But you can right now understand topic as a simple PI tag. Is something that stores data for you. So Tech Lab View, that's the name of the topic that is going to publish. If you have already created yours, you can click here, Get Topic. It's going to expand the list of topics available, and you can select any topic that you want to publish it to. I'm going to use this one here, Tech Lab View. I like the name. I'm going to publish, and there you have it. It's working. You have to believe me because you can't see it right now. So let's now talk a little bit more about what is Kafka and what we have done here. So let's recap. We are generating data, live data. Let me just go to statistics. We're generating live data. We're sending through PI Web API to a PI server. From the PI server, we just configured a PI Integrator for business analytics to get information from a specific group of elements and stream this data to a Kafka server. All right, so let's talk about Kafka.
Quick question.
Yes, sure.
If you were to add another wind turbine K, would it automatically
Yes.
go in there, or do you have to?
Yes, it will automatically because it's looking for the template, not the elements. Yeah.
That's specifically because you use the template.
Yes.
If you didn't use the template, it would not.
Exactly.
And if the template changes?
If the template changes, well, we have to be very careful here because, for instance, if you change the name of an attribute, or if you, no, but here we specified a specific attribute. So it's not, if you add a new attribute, nothing's going to change. But if you remove the attribute that you're using, this view is not going to work anymore. So you have to be careful when changing. So let's go back to our presentation. I've been talking about Kafka, but what is Kafka? So Kafka is an open source stream processing platform, and that's it. It allows you to send data to Kafka, and consumers are able to consume the data they are sending to Kafka. It is very robust. It's able to handle a high throughput, and it's very low latency. If you have a very good cluster of Kafka servers, they are very reliable. And this is a very simple architecture of Apache Kafka. Apache Kafka allows you to have those producers send data to a cluster, a Kafka cluster, and consumers are able to subscribe for specific topics. So that's why I mentioned that topics are like PI tags. The information that you are sending to Kafka, they are stored here inside the topic. And when I mention stored, they are not exactly stored. They are available for a specific period of time. You can configure that. You can say, I want my data to be available for 24 hours. So anybody that is able to subscribe to a topic, it's able to get the past 24 hours of data. Once the data is over this threshold, it's deleted. Also, you have partitions. So inside, a topic is divided in partitions, and that allows you to have multiple servers serving multiple consumers. They are reliable. If one of the servers fails, you have data replicated. And going back to our architecture, I mentioned producers and consumers just to give a better understanding here. Our PI Integrator for business analytics, it's a producer. It's sending data to Kafka. The Spark cluster that's later going to consume this data, it's a consumer. In the same way, the NodeRED, it's another server that we're going to talk soon. It will be also a consumer, getting data back from Kafka and sending to PI. So let's see Kafka in action. Which one? The third one, okay. The second one, actually. Hey, so it's Kafka. Let's first create an example here for you to see Kafka in action. This is, okay, I have a specific user for my Kafka. There you go. So, because it's too small, I'm not going to type. I'm going to copy and paste here. Okay. Why is it not pasting? Please write paste. All right. Okay, there you go. So what I'm going to do right now, I'm going to create a topic. I manually create a topic. By the way we used the integrator before, it automatically created a topic for you. But you can create one your own. And once you create, you can specify a replication factor and the number of partitions. I'm not going into the details of what that means, but that allows you to have data replicated through multiple servers. Because right now I have only one single server for my Kafka. There's no need for you to have a bigger replication or a huge amount of partitions. I only have one subscriber. So that's it. I'm going to create a topic.
What range would the topic the integrator created be at? Would it have been one that represents the entire stream, or for each, some one of the attributes?
So what it will be a little bit clear when you see the data being sent to the integrator. You will understand what's going on. I will go back to your question in 5 minutes. So, so we just create a topic, a tech lab topic, all right? So where's my mouse? It's here. So let's manually send some data to it. So what I'm doing here, I'm asking Kafka to run this script. It's a producer. It's going to produce data, to send data to Kafka. I'm specifying my server here, the port that we're running, the topic that we have just created, the tech lab topic, and I'm going to send hello world, and that's it. So let's run. Okay, there you go. Wow. Sorry. So let's see what happened here. So we send hello world to a topic called tech lab topic. That's not very impressive, but let's consume that topic. Remember that I mentioned that there is some, the data is stored for some moments. In our specific server here, I configured it for 24 hours. So if I do tech lab topic right now, you see nothing. Because there's no data coming. There's nobody sending data to that specific topic. But if you come back here and ask from beginning, is it right? I think so. I cannot read it. Okay, hello world. There you go. It's still not impressive. So instead of this, let's go. Instead of, okay, here. I don't remember the name of the topic that we have created. Yes, a tech lab topic. Tesla. Oh, it's better to check. Okay, instead of checking, let me. There we go. So I know this one is working. So it's configured to be the same thing. So what we're seeing right now, it's what integrators do. Integrators sending that data that we specified, the turbines, the speed, the timestamp, and the name of the turbine is sent to Kafka. Now it's getting more interesting. Now we have real life data coming from this little fellow here through the PI server to this Kafka server. And now it's getting interesting. So yes?
So there's no real, I'm no Kafka expert at all, there's no real type in essence, you're just stringing.
Exactly, there's no type.
You send a hello world string and now
it's a blob.
It's just a binary.
You can
bytes that you start recording, it doesn't really care what you send it.
Exactly. It can be string, it can be something serialized. You can use Avro serializer to send data here. There are several things that you can do with Kafka, and that's the beauty of it. There's no need for you to conform to a specific format. You can create your own. In our case here, it's a very simple JSON array and that we can consume.
So that fact that it can spit out a JSON array is really driven by kind of how integrator is configured, right? Kafka is going to knows to use this format.
Exactly.
Each JSON object is still recognized as being like a distinct object, though.
Yes. Yes. Internally, Kafka, when sends data to a consumer, it not only sends a string of strings. It sends partitions, it sends timestamp information, some metadata to allow you, when you go back to Kafka request from the point that you stopped. It's a little bit more complex than this. Kafka allows you a lot of flexibility when it comes to storing information and metadata related to the data they were sending. And now let's go back to the presentation. So there, oh, I can see it. Okay. So where you are right now, we're sending data to Kafka. All right. And what we're going to do right now is to consume that data and to try to extract meaningful information out of it. And then we're going to talk about Spark a little bit. So Spark is an open source distributed cluster computing framework. It allows you to deploy a model that you have created before, to run on Spark, to get data from Kafka. not only from Kafka, let me go to this one here. Not only Kafka, but several other platforms allows you to get those data, to apply intelligence on top of it, extract meaningful information, and you can get the data and send back to whatever you want. In our case here, we're getting data from Kafka, and we're sending back to Kafka. That's what we're going to do today. But those are some examples of other platforms that we're able to talk to. By the way, this kind of integration that I'm doing here, I'm using Kafka and Spark because I want to. You could easily use any other platform. You could use Azure Event Hub and Azure Machine Learning to do it and send back on the same way. There's no specific reason for me to be using Spark or Kafka. And so let's talk a little bit about Spark. So Spark, it's a cluster of computers that they work together and allows you to deploy an application to it, and that application runs on the cluster. It extracts information. It's able to replicate data to several nodes. It's able to replicate the execution of the program to several nodes and do all the processing. If you are familiar with Hadoop, you may be realizing now that's pretty much the same architecture of Hadoop. And it's not only the same architecture. Kafka is built on top of Hadoop. So any type of map reducing that we're used to do on Hadoop, you can easily do on Spark because it's the same engine. Spark also runs on Java or Scala. So if you're used to use Hadoop, you will feel familiar on Spark. But there's a big difference here. So in a couple of minutes, I'm going to show this. But when you have a job running inside Kafka, you open it to see the details. You see this. You see exchanges, shuffle, project, aggregate, exchange it. And if you are familiar with SQL, the way queries run on SQL databases, you feel familiar with this nomenclature. And the reason is that Spark, it uses a very SQL-like language. And that's challenging because most of us are used to do a very straightforward programming. We are used to do, how it's called, procedural programming. That was the word we were looking for. We're used with procedural programming. Get A plus B equals C. Spark, it's not procedural programming, it's declarative programming. So you have to talk and you have to code the same way you'd code a SQL query. And that's a little bit challenging. So let's go back to our terminal. Actually, let's go back to my computer here. It's still generating data. Good. Okay. So I'm not going to explain everything here. I'm going to briefly go through, that's the code that we're using to process the data that we are generating. So it's actually pretty simple. Oh, Chuck. I really don't know what's going on. I close it and comes back. All right. So the language here is Python. If you're familiar with Python, it's Python. You can easily deploy a Python program inside Spark, even though Spark was built using Scala and Java. You can use Python to deploy applications. So if you're familiar with Python, it's a good thing. You just have to import the PySpark library. So what we're doing here, we first specify the schema of the data that we're importing. Once you do it, we create what we call a context and a streaming context. So we can get the streaming data. I'm setting the level here of the log to warn, so it's not that verbose, would be easier to read. I'm getting the topic from the input that I'm going to write, so I'm going to call my application Spark PI space the topic name that we're going to subscribe to. So I create a direct string. I'm here asking the producer to serialize the information that, see? That's another boss. So I get the data, and what I'm doing, it's a little bit hard to read. It's why the line is. Okay, so I'm asking the data to be serialized to the producer. Oh no, I'm here already sending data back to Pi. Sorry about that. So I'm getting my stream here. You can see the stream, right? This guy here is the producer. I mentioned that I'm going to send data back to Kafka once I prepare it. So this is the producer that we're going to use. It's going to send data to a specific topic that we're going to request. And then comes the fun part. Let me go down here. It's the process data. The process data is just a method that we call every time new data comes. And what I'm doing here, if you notice here, when I create a context, I specify a minimum amount of time. So what I'm saying here to Spark is to wait at least 60 seconds of data to buffer. Then we process it. Then we go to the next batch of data. That's what we're doing here. And the process data itself, it's actually pretty simple. It's just a series of transformations, aggregations, and what I'm doing. And by the way, I didn't mention, what I'm trying to do here is, remember that we're generating our data following a specific correlation matrix. The only thing that I'm going to do here is to get the correlation matrix from the actual data that we're generating and send it back to Pi. And so I'm pivoting the data. I'm wrangling the data here a little bit just to calculate for each combination of columns the correlation of them. And I'm using a very simple Pearson correlation. Nothing fancy, nothing special. I'm pretty sure this would be pretty useless in real life. I'm not here to show how to use Spark. I'm just here to show you how you can do it. And once we prepare the data, we generate a second JSON. A JSON with element A, element 1, element 2, and the value of correlation. So our JSON will be something like A, B, 0.3, B, C, 0.4, and that's it. Very simple. So let's run this bad boy here. All right. So it's this guy here. So let me. Okay. So what we're doing here, we are asking to run our script. It's that Kafka processor.py. I'm passing the information related to the address of my Kafka server. The topic that I'm consuming from and correlation result is the topic that I'm going to write to. And that's it. So now we wait a little bit because Java. OK, now it take a while, right? So meanwhile, let's go back to our, if I can find the mouse. Where's the mouse? OK. So it's clear. Another email. Oh. There you go. Is that right? Okay, so let's go back here. It may take a while, right? For some reasons, the first one is because I was a very cheap guy and I decided to go with the very, very small server. I really regret that. The second reason is because I'm actually, my script is ensuring that the data it's good to be processed. So that means that it's going to take a little bit longer than 60 seconds in real life. In our scenario here, it's taking from 2 to 3 minutes. But it's not a big deal. We can proceed with our talk here, and then we get back later. Okay, so let's talk about NodeRED. Okay, you guys are not familiar with NodeRED. Okay. No, sorry. NodeRED is a flow-based programming tool. It's a development tool that allows you to easily drag and drop boxes that do actions. For actual software engineers, coders, and developers, this is very, very frowned upon. People say, huh, really? Well, but I really think that this actually has a very good marketplace. Allows people who are not that familiar with software development to do actual software development. So that's why I decided to send data back to Pi using NodeRED. We could usually have a Python script getting the data from the Kafka producer and send it to Pi. But nah, that's not fun. Let's use NodeRED. So NodeRED, it's a consumer here. It's getting the data from the correlation results topic, and it's sending data back to the Pi server. So what is NodeRED? This is NodeRED. Allows you to get like an HTTP generator. You specify anything like an endpoint. You can convert it to XML and store as a file, and you can leave that running. For instance, if you have a equipment generating an XML log, you can store that log from time to time. You can monitor a specific file, and if the file has a value that's above a specific limit, it can trigger an UDP packet or can make an HTTP request for you. So you can easily drag and drop boxes. So let's see it in real life. Is it still? Okay, still calculating. It's taking longer than usual. I don't know why. Oh, but it's already sending. Okay. So you can see here, we have a pair, EF, a timestamp. Oh, let's get another one. This one is a very bad one. One we can read, actually. So here, CF, timestamp, and the correlation value. So we are sending this data to this specific topic, and that is it. So let's go back to NodeRED. Where is NodeRED? Okay. So this is NodeRED. It's very simple to use. It has a very active community. So if you have questions, it's easy to find answers online. And what we are going to do here, we are going to use, you can see we have our input. No problem. This is a big family. You have the input boxes, you have the output boxes, you have functions, so you can create your own functions. And it has some specific functions for social information, like to subscribe for a specific tweet hashtag, and then you can real-time process it, like to get how it's called when you get information from crowds, feeling information. If people are happy about something, sentiment, thank you, sentiment information. So in our case here, because I was going to do it live with you, but it's really hard for me to read what I'm doing. So I'm going to switch to my backup and explain what we have done here. I think it would be easier. So we start with a subscription to our Kafka topic. And it's the correlation results topic. The correlation results topic, if you double click it, you can see the same server we have seen before, the topic that we're subscribing to, and the group ID. Group ID is something related to Kafka. If you guys want to talk a little bit about later, I can explain what it is, but it's just a way for you to group consumers in a single group. Okay, there's it. And then you can specify the payload from this topic to be sent to a JSON converter. This box here, it's only getting the JSON that is coming through this guy here and convert it to a JSON, and that's it. Pretty simple. No need for you to create a JSON parser, nothing fancy, nothing special. And then you get the JSON that is coming from here, and you send it to another topic, to another box. It's the splitter box. What the splitter does, it gets each element from a JSON array and processes it individually. So because we are sending a batch of pairs, of correlation pairs, we're going to process each one of them individually. And that's why I have the splitter. And let's go back here to the Kafka. Oh, no, it's here. OK. Remember that we're sending pair CI. There's a reason why I'm doing this. And let me show you why I'm doing this. So the way that I decided to use my server, my AF server to store this information, is actually not very efficient because you cannot grow this. But it's just a simple way for us to store the data. So we have an element, the hierarchies element, and inside of it you have attributes for each correlation. So we have correlation AB, correlation AC, correlation. I know it's not efficient. You can judge me. So we have the splitter. So you have correlation under A under B, correlation under B under C. So we know the path. We know that's / hierarchies / attribute, actually pipe attribute. So what NodeRED allows you to do is to get the information from the payload and apply some code to it. And what code I'm going to use here? The same one that we have used before to generate the web ID. So what I'm doing here, let me expand. So here's the payload. I store as a variable. I have the full path here, and I get the pair. You guys remember that we had a JSON attribute called pair. So it's correlation under A under B. That's why I decided to do this. It will be very simple. The header, you may remember AB for attribute and E as the owner, the type of the owner. We just do a simple base 64 encoding here. We concatenate the string and return the message with the encoded web ID. This is the very same code that we run before. The difference here is that's JavaScript, not Python. So far, so good, what we have been doing.
Do you have to prime that element with all those attributes ahead of time? Or if it tries to write to the attribute that doesn't exist, would it add it in AF?
Because, no, it's not going to be added on AF. You can write a function here to detect if it's not there and create the attribute for you. It's not hard to do it. But so yes, in that case, you
If you had a new wind turbine, you'd have a whole bunch of permutations that it's going to start reading.
yes. That's why I said that the way I did it's not very efficient. You could store an array inside Pi, but I think that the way I did it's a little bit more clear about what I'm doing. If I would be doing in a real life scenario, I would store an array, not a specific element. So continuing here, once we have our web ID, what do we do? It's just a simple transformation of the payload. So I'm deleting the pair. I'm changing the name from correlation to value. I'm adding an attribute called good to true, questionable to false, and changing timestamp from to caps here. For those familiar with PyWeb API, you may start to see a pattern here. What I'm doing, I'm actually getting the JSON that we just got from Kafka, and I'm converting it to something that PyWeb API can understand and can process. So that's very simple. So I change it. I create 5 rules of change here. And then, finally, what I'm doing, I get the URL to our PyWeb API. I specify a verb. In our case, it's a post. And so, yeah. So what I'm doing here, you can see that I have the URL /PyWebAPI/streams/WebID, because the WebID is already encoded on our payload. So this is called mustache notation. It's a you like it? You like mustache notation? Yeah, me too. So mustache notation is a template system. Allows you to use mustaches and get information from out of your JSON inside the actual URL that you're sending. So you're sending the content from this guy here to this address here. I'm using a basic authentication. Gandalf, by the way, the password is "you shall not pass." And that's it. I'm doing posts for each of the JSON elements that we have here. And finally, this is just a debug tool. Allows us to see the results from everything that we have sent. So here I'm getting the payload from the HTTP request and seeing the contents of it. In our case, because it's an HTTP request, the payload will be the response from the server. So basically what we're going to see, it's a 200 OK response from the server that says that it was a good. There you go. So if we expand, so we can see here, the topics correlation result, the web ID is this guy here, that's the response URL, and the status code. So what we have done here, we got from our topic data, we converted to a JSON, we processed individually each one of the elements inside that JSON array, we encoded the web ID, we made some small changes to the format of the payload, and we sent to PyWeb API using a HTTP request box. So if you go back to you can see that, you have data coming here. All right, and what we can do with that data? That's the nice part of the presentation. Now let me bring this back here so I can read it, because it's so. Where is? Here it is. let's go back here. Let's refresh this screen because now we have correlation data coming. It may take a couple of seconds here, but eventually, hopefully, it will work. Oh, the anticipation. There you go. And I'm using 3GJS to produce this heat map. And that's it. That's you could use vision here. I wish I had time to use vision, but I didn't. Sorry about that. But the way I created this one, it's a very simple vision symbol. You could easily import that to vision. It's not a big deal. Any questions here so far? So let's go back to our presentation. Okay. So what we get from it? What's our conclusion here? What? It's changing. What? All right, so we wrote very, very complicated code. Everything worked fine, and and PowerPoint's not working. Oh, there you go. So the conclusion here is that it's easy. It's very easy to send data out of the PI system using PI Web API, using Integrator for business analytics. We're using Kafka, but just as an example, you can use any platform. It's really easy to do real-time analytics with PI data. It's not hard. It can be intimidating to configure everything, but once you have it running, it's very robust and very reliable. And especially easy to bring data back to PI. You see, with only 7 nodes, we're able to bring data back to PI with not much effort of writing code. And by the way, if you have questions related to how to write code using PI, you can ask us on PI Square. You can. It's a very active community. I invite every one of you to see it. Here, here, gorgeous. Here is. Here's my email address if you want to get in touch with me later, if you want to ask questions. I'll be here until Friday if you want to talk a little bit more about what I have done here, what's going on. I can show you that we actually did it live. I'm not faking it. And that is it. I hope you enjoyed the presentation. I invite you, there's a survey on the app that you can go through. You can give your feedback on the presentation. I invite you to go for it. And let's open the stage for questions. Any questions?
I guess more of a performance question. How much or how fast can, events per second can the integrator for BA send stuff to Kafka? Is it scaling tricks to spin off other threads or more services or workers or something?
So it's pretty much what we see on the real life here is that most of the times network is the bottleneck. You have to have a good network. You have to have a good server to process everything. There is an official limit. There is, but I don't know the number. I can ask the product manager to give you. But it scales really, really large. You don't need to have a concern about the integrator's capability here. It's much more bottleneck when it comes to network and when it comes to processing the data than actually the integrator itself. But if you want to find me later, I will call the program manager, the product manager. Yeah.
Scales by design, Kafka scales by design.
Mm-hmm. You can scale integrators. You can deploy multiple nodes of integrators as well. Here we're using a single node, but you can actually have multiple integrators.
On the topic of scaling, as you scale Kafka, you can give strategies of multiple partitions and multiple consumers and such like. What strategy do you use to maintain order in your time series? Because the minute you start to scale, you go across multiple partitions, and now you've got data points in different partitions. How do you maintain order?
You don't need to worry about that because it's automatically. So as I mentioned here before, Kafka, it's not only a single blob of data. It has a lot of metadata attributed to it. There's a way to see it. It's a little bit cumbersome. I can show you later if you want to. But this metadata, it has information like what time the information got in the server, what partition was first assigned to, so allows you to replicate correctly to multiple partitions. And because of the metadata, you can synchronize everything seamlessly. It's not something that you should worry about.
Any examples in industry of people using it to find correlations like this? Insofar as what would be like their kind of approach? Would it be mostly just a developer working hand in hand with a business partner? Or is it more developer spinning up like reusable tools and kind of making a boilerplate template for a business user to kind of spin off?
Okay, so this is a real example. A company that I know is using the integrator and a very similar architecture that we have seen today to look for patterns, pattern matching. And the way they did it is using their own IT team. They have software developers on their IT team, but most of the guys who did the workflow were actually data scientists. And
Our experience is this isn't like an end user or operator tool or anything like this. This is getting it into sort of open source.
yes,
For data scientists alike.
yes, but actually, the data scientist is not the most capable person to set up this environment. You need IT to do that. You need IT to configure a Spark server. But once you have everything set up, it's actually pretty simple for you to deploy new applications. So in that specific case, this company is using data scientists to generate models, and the model is deployed to Kafka through a portal, and that's it. Any more questions? No? So I think that's it. Yes, that's it. I hope you enjoyed. I hope you like it. Thank you.